In the Big Ten, the NCAA Sports League, a sample showed that only 275 out of 584 freshman football players graduated within 6 years. At alpha equal to 0.05, does this sample contradict the claim that at least half graduate within 6 years? Okay, it looks like this is going to be a test on proportions, and we are testing the claim that at least half of the freshman football players graduate within 6 years. So we'll assume that the population percentage is at least 50% or 0.5. And then our alternative would be what's contrary to that it's actually less than 50%. Now, let's go ahead and see what evidence we have from our sample proportion. 275 out of 584 graduated within 6 years, and that turns out to be 0.471. Well, this sample is evidence against the null hypothesis, so let's go ahead and run a test and see if this evidence is strong enough to reject the null hypothesis and prove that the actual percentage is less than 50%. So I'm going to go ahead and run the test. I have evidence here to refute the claim possibly, and I want to see if that evidence is strong enough. Keep in mind that all we have is a sample. We don't have the whole population, so this is just going to be evidence. We're going to go ahead and build the sampling distribution. We're assuming the null is true, so that our overall population percentage is 50%. So that's exactly what's going to go into the standard error formula. And our sample size at 584. Now keep in mind that in calculating the standard error, I'm taking the square root of that whole value there and coming up with 0.0207. Also, I have a level of significance, alpha equal to 0.05. And since we're working with proportions, this is going to give me a critical value of negative 1.645, lower tail test in this case. My rejection rule, step 3, I'm going to reject H sub 0 if my sample percentage has a test statistic Z less than the negative 1.645. In other words, it's far enough out to the left, it's past my decision line, that gives me confidence to go ahead and reject the null. Let's go ahead and see what the test statistic is. How far away is the 0.471 from the claimed 0.5 in standard units? And that turns out to be a negative 1.4. So in step 5, we're not quite far enough out to go ahead and feel comfortable in rejecting the null. So we do not reject H sub 0. The evidence isn't strong enough. When we set our level of significance alpha, we were willing to risk 5% to make a type 1 error, but our risk is a little high here. We're not quite far enough out. So we're not willing to go ahead and reject. At the same time, we are not willing to say that the null is true, that H sub 0 is true. We're just saying that the evidence isn't strong enough to reject it. So the test in some sense is inconclusive. There is not enough evidence to prove that the population percentage is less than 50%. Now, the test is done. It's inconclusive. I ended up with the do not reject. And I want to go ahead and show how to run this same test using the p-value. So I'm going to go ahead and look again at my sampling distribution. My sample percentage or proportion 0.471 has a z-value of -1.4. That's also called my test statistic. So in other words, the 0.471 is 1.4 standard units to the left of the center, which puts that 0.471 about here in the distribution. Now, its test statistic or z-value is -1.4, which was greater than the -1.645. So we didn't reject. What we want to do is calculate the p-value. Now this is a one-tailed hypothesis test, so the p-value will be essentially the probability of getting anything less likely than the 0.471. And to calculate that, we'll calculate the area under the density function for the sampling distribution to the left of the 0.471. And to do that, we will look up -1.4 to get that our p-value is going to be 0.0808. And that is greater than the risk that we were willing to take at 0.05. So our sample percentage was not strong enough evidence to reject the null hypothesis. The p-value for that is greater than our level of significance, so we conclude do not reject.